This question says, enter the chemical formula of a binary molecular compound of hydrogen and a group 4A element that can reasonably be expected to be less acidic in aqueous solution than GeH4, e.g. have a smaller Ka. So the smaller the Ka of something, the less acidic it is because the less H3O plus that it forms. Remember that Ka equals H3O plus times the conjugate base over the acid. So therefore, the more H3O plus there is, the larger the Ka. Said another way, the more acidic it is. Well, we want something that's less acidic than GeH4, but it also has to contain a 4A element. So if we look at our choices for 4A elements, we have carbon, silicon, of course germanium, but that's the one we're comparing to, tin and lead. So the question is it carbon and silicon or tin and lead? Is it higher on the periodic table or lower on the periodic table? Well, in this case, we're looking for something that has a smaller Ka or is less acidic. So we want to choose either carbon or silicon. So the two choices here are CH4 or SiH4. And a simple way of thinking about this is the CH bond distance is shorter than the GeH bond distance. Therefore, the CH bond distance is stronger than the GeH bond. Since this is a stronger bond, it's less likely to lose a proton. Hydrocarbons like CH4 are some of the weakest acids that there are when it comes to these covalent compounds. Let's look at the next question. It says, enter the chemical formula of a binary compound of hydrogen and a 6A element that can reasonably be expected to be more acidic in aqueous solution than H2SE, e.g. have a larger Ka. Well, let's look at the 6A elements, and again we're comparing to H2SE. So if we look in 6A, we have selenium here. So the question becomes, is it sulfur or oxygen, or is it tellurium? Polonium is kind of a man-made element, so we're going to skip that one. So basically, we want to know, is it tellurium or sulfur and oxygen? Well, we want to have a larger Ka. We want something that's more acidic. Said another way, we want something with a longer bond distance. Both oxygen and sulfur bond to hydrogen will be shorter and therefore stronger and less likely to break and make it less acidic. So H2Te with its longer bond distance or weaker bond between tellurium and hydrogen will be most likely to break. So that's essentially how we solve this problem.